Okay, this is the new chapter, chapter 7. It's about function, limits, and continuity. First, it's divided in many parts. I will start first with the first part. It's a little bit revision from last year, how to find the domain of a function. It's very important. So, part 1 is the domain of definition. The most important part that you need to think about are the radicals and the fractions. And when you see radicals, sure, there is a domain. When I see a fraction, sure, there is a domain. So, to explain this part, I just want to use some examples. Let's see the first one, okay? So find the domain of definition of f of x equal x4 minus 2x squared plus 3x minus 1. This one, there is no radical inside, and it's not a fraction. So my domain is minus infinity plus infinity. It means I don't have any problem with any x. If I replace x by any value here, miss, I have a root. I have a solution. I don't have any problem. If I look at the second one, f of x is equal 1 over x squared minus 4x plus 3. It's a fraction. It's a denominator. That is a denominator. And we know that fraction exists when my denominator is not equal to 0. Okay? So x should be not equal to 1 and x should be not equal to minus 3. So here you use your calculator to find the roots. And how are you going to write it as domain of definition? This is my number line, okay? The not accepted values are 1, this one, and 3. So how am I going to write the domain? I'll start from left to right. So it's minus infinity 1, union 1, 3, union 3, plus infinity, okay? Let's go to, it means if you replace your x by 1, the denominator you have 1 over 0, it's undefined. You know that, I'm sure you know. Another example. Here it's example 3, it's a radical. So radical x squared minus x. Also, this expression exists if under the radical is bigger or equal than 0. It could be equal because it's not in a fraction, it's just a radical. So x squared minus x bigger or equal than 0. Here we need to go to the preceding chapter. You remember the table of sign. But to be able to do the table of sign, I need to have the roots. I can all factorize like this I did here. Or I can use my calculator. A is 1, B is minus 1, C is 0. And the roots will be 0 and 1. Then I will do the table of sign as we did in the preceding chapter. The sign is same as A, opposite, same. When this one is bigger or equal than 0, it's for minus infinity 0, union 1 plus infinity. It's included 0 and 1. But if you saw here, if you had it 1 over radical x squared minus x, here it should be strictly positive. I'm not allowed to have equal to 0. So the domain will be without the boundaries. So it's open. It's not a closed domain. So the domain of this one, it's open boundaries because it's in the denominator. So if the radical is in the denominator, it's strictly positive. If the radical is alone, it's a polynomial, but with the radical, it's bigger or equal than 0. Let's move to another example. Part 4, here you have it as an absolute value. So if I can have, for example, f of x equal radical of absolute value of x. Why my domain is minus infinity plus infinity? Because I want that everything under the radical should be bigger or equal than 0. Yani radical of absolute value of x should be bigger or equal than 0. But this one is all the time true for all x. Because for any x, if you put x minus 10, you will have absolute of minus 10 is 10, then it's radical 10, so it's true. For 5, my denominator cannot be equal to 0. So absolute value of x minus 2 not equal to 0. It means absolute value of x not equal to 2. It means I have two possible values for x here. Or 2 or minus 2. Why? Because if you have inside here 2, absolute value of 2 gives me 2. If you have minus 2, absolute value of minus 2 also will give me 2. So the two unacceptable values are 2 and minus 2. So what will be my domain of definition? And if I want to put my number line here, this is minus 2 and this is 2. Those are rejected. So I will write minus infinity minus 2, union minus 2, 2, union 2 plus infinity. I hope that you can see the writing easily. Okay, I think this is the last one. Let's check it. Yes, that's it. That's it. This is the first part. Okay, now the second part, how to calculate the limit graphically, we will do it later in another video. That's it.